Hi, my name is Andrew McLaren. I want to help you with working with vectors or components. So if you have like some sort of force, typically force of gravity, you have to break down into an x and y component on a slope. Um, and you have to work with like the theta. So they might be like, oh, it's a slope of 30 or a slope of 20 or something. And then you need to figure out where that 20 or 30 goes in these triangles, which if you do it to scale, you can kind of visually see it, but it can be tricky for a lot of people. And basically what I do is I just say, okay, the x's have rotated by 20 degrees, the y's have also rotated by 20 degrees. And so you can kind of see that in this picture. I'll go over a little bit more soon, but basically this red one is correct. That is where the 35 degrees should be, and this is not correct. But this is the if you look at the complementary angle, they should add up to 90. If we look at those two different angles there, which kind of makes sense because like if you had like 30, the other one would have to be 60. Um, which means you can also kind of relate it to the other angle that's at the bottom of the triangle as well. You gotta be careful. But I'll go over the triangle and how to do that soon. So before we go into the trick a little bit more in detail, it's important that we talk about why we need to draw the triangle because a lot of the times theta that they give you, it will be like 30 degrees right here. And so it's relevant to the x-axis. And so it's like, okay, 30 degrees up from this x-axis. And so you can then relate like sine in this case is related to y, I believe, and then the cosine would be related to the x. And so you can then, in that case, kind of generalize it like that in some ways. But you have to be careful because sometimes they don't give you the angle under; they kind of give you the angle like above it relative to 90 degrees, just straight up, or like you know, just up. So like in this case, you can see right here they gave you the angle kind of above um, the string as opposed to below. And so you could work with the 60 degrees or you could work with the 30. It really kind of depends on which one you want to work with. So I think in this case, we did the 60 with this student. Like we, instead of working with the 30, we worked with 60 degrees. And that kept our adjacent was our x-axis piece right here with the 60 degrees. So I was able to use my cosine for that adjacent, right? Because cosine is adjacent over hypotenuse, and in this case, the adjacent was the um, that force in the x direction, that second tension. So you can kind of see that this is the main idea is that you need to draw in your triangle so that you're not just assuming that because most problems the angle that they give you is relative to the ground, but you don't want to assume that. And I've had some AP students that have that assumption, and it's not true, and it kind of messes them up. So just be careful with that. So this is the common way of looking at a slope. They usually like to have it so the right side is higher up and the left side is lower down, and they'll tell you like, oh, it's at a slope of 30 degrees or something like that. And so what you've done is that you've taken the x-axis and you've kind of rotated that up 30 degrees. So the y-axis has also rotated 30 degrees, or I suppose because the camera it might be flipping it. But in any case, the x's and y's rotate together. So the difference between like the old x and the new x, that's going to be that 30 degrees. And then the difference between the old y and this new y that's relative to our slope, you kind of like look at it from the slope, that's also going to be rotated 30 degrees. So you can see that that rotation then is pretty easy. And then you can be like, okay, well, now this guy on the bottom here, this is parallel to my x-axis. So this is the x component. And then this would be my y component right here. And then I do always do my sine and cosine and tangent, the SOHCAHTOA, because that just helps me with this. And then I can be like, okay, well, I've got theta. If I wanted to relate opposite over hypotenuse, that would be for sine. And so sine of 30 degrees here then is going to be the opposite, which is that fx. all over the original force, this F right here. So that's how I would go through working on one of these problems. Is just kind of like, okay, well, the y's have shifted that much, so now I need to rotate the whole thing that much. So here you can see is a problem where I actually used this technique, where I had the old and the new, and I knew the rotation of, I think that this was 35 degrees. But you can see that I've got my triangle here, and I now know that this is the 35 degrees, not the complementary angle. You know, that's not what we're looking at, but what we've got is gray right here for theta, and right there, that's going to help us with making that triangle, right? So then once we have that triangle and we have our sine and our cosine, then we can actually get the values and magnitudes of those forces, which then with FGX and FGY, you can then sum that, you can put that into your sum of forces equations and use that, right? So this is going to be vital for working on a lot of these problems, trying to get like the acceleration from those different forces. Just keep in mind that the force of gravity is very commonly used on these problems, and so you're going to have to get good at rotating gravity and saying, okay, that was y, but now this is the new y. What's the rotation from that, right? So if you're in AP Physics or college physics, Atwood machines and the slope kind of modified version of Atwood machines, they're pretty common, where they'll have like two masses on a pulley and they're pulling on each other, and basically they have these two different slopes. And so this is going to be very useful, being able to look at your y, like the new y and the old y, and get that theta. Because if you're looking at these two force diagrams, they're kind of like mirror images of each other. And so it's really, really important that you've got good labels. And so I've got like y1 and x1, and then this is x2 and y2, just to help myself figure out what I'm talking about, like box 1 and box 2. So that's a good thing to use in conjunction with this angle trick, where I'm like, okay, well, I know that that's going to be the 50 because that's my new y, and this was where my old y was. And same sort of deal, but now we've got a different slope. Now this is my new y, and so I have to have my theta, that rotation of the xy, being 30 degrees, so that would be 30 degrees in there, right? So you can kind of see that the 30 is there. So you got to be careful with that, and if you get that done correctly, then you should be able to do these Atwood machine problems and get the pieces put together. Because otherwise, if you put an x where y should be, all of your math is going to get affected. Thank you for McLearning with me. Before you go, please check out the following services that I offer with my business. So if you click the link in my videos, this goes to my website. I might be changing it from Podia because I'm no longer doing the interactive videos for sale. I might put those up for free. But most of my other services are linked here. So you can see that I've got like a Teachers Pay Teachers and a Wyzant. The Teachers Pay Teachers has a lot of my assessments that I have for like the NGSS, as well as lessons that I made when I was actually a teacher in the classroom. So I've got quite a few things like CERs and other things on there. If you want to get one-on-one live support from me, either like with science or like working on like teaching support lessons and that kind of stuff, you can sign up through Wyzant. I have a link to there where you can contact me there. And we can schedule hourly appointments. And I've got a few other things on here, like a Facebook page and other social media. And if you're interested in getting professional development with me for like a team of teachers, a whole page with information on that. So yeah, feel free to check that out. Thank you.